Okay, in the last video, we came up with a conjecture about an inequality, and now we're going to attempt some algebra to see if maybe that'll help us prove the conjecture. Here's what our conjecture was, that the stuff on the left is greater than or equal to the stuff on the right. Well, first of all, what I'm going to do is square both sides, and I have to verify that I can actually do that and keep the inequality symbol going in the same direction. So this is stating that if you're dealing with two non-negative numbers, a greater than or equal to b, and they're both non-negative, that when you square, a squared would still be greater than or equal to b squared. Now that could actually be shown with calculus if you know calculus. Not everybody that might be watching this necessarily knows calculus though, but you're dealing with the restricted domain starting at 0 and continuing to infinity, then y equals x squared is an increasing function. But I'm going to approach this a little differently. Subtract b from both sides in the inequality a greater than or equal to b. Notice that everything we do along the way here, we're never going to be multiplying or dividing by a negative, and so nothing is going to change the direction. So when I've subtracted b from both sides, a minus b is non-negative. What I'm going to do is multiply both sides of that by a plus b. Since a and b are non-negative, a plus b is going to be non-negative. On that left-hand side, multiply the quantity a minus b times the quantity a plus b. Distribute or FOIL, or use the special product formula of the difference of two squares. Whereas on the right-hand side, multiplying that by a plus b, since we're multiplying it by 0, we know what's going to happen there. So by applying the difference of two squares over on the left, we have a squared minus b squared, and that is greater than or equal to 0. So add b squared to both sides, and we have what we want, that when a and b are non-negative, a greater than or equal to b, then a squared is greater than or equal to b squared. So I will proceed, going back to what was being claimed, squaring both sides, knowing that I will be keeping the inequality symbol in the same direction. And furthermore, any adding, subtracting, multiplying or dividing, since we're not going to multiply or divide by a negative, that will continue to keep the inequality symbol in the same direction. So, squaring both sides. And then on the right-hand side, since what we have underneath the square root on the right-hand side is non-negative, in fact, it would be greater than or equal to 4, then we're going to get cancellation. On the left-hand side, I will have to distribute or FOIL, or I could use a different special product formula. In this case, on the left-hand side, you don't just get the square canceling out the square root over 1 plus x squared, and similarly, the square canceling out the square root over 1 plus y squared. We get in the middle also 2 times the product of 1 plus x squared under a square root times the square root of 1 plus y squared. And I skipped a step here, but you can apply the product rule for radicals to put the multiplication of those two radicals underneath a single radical. Next, on the right-hand side, I'm going to multiply out the quantity x plus y squared. Same deal, either distribute or use FOIL or the special product formula. We will not just get x squared plus y squared. We will have in between x squared and y squared a plus 2xy. So next, I'm going to combine like terms on the left, and the only like terms I can combine are the two ones. I will then subtract 2 from both sides, x squared from both sides, and y squared from both sides. Again, since we're not multiplying or dividing by a negative, that's not going to change the direction of the inequality symbol. you can factor out a 2 on the right-hand side so that you would have 2 times the quantity 1 plus xy and divide both sides by 2. Again, we're dividing by a positive, not a negative. And so that's going to keep that in the same direction. Now I'm going to square again. And again, we saw back up here at the top that if you have two things that are non-negative, one thing is greater than the other, then the square of what's on the left would be greater than or equal to the square of what's on the right. On the left-hand side, that's going to cancel. And on the right-hand side, I have, again, distributed or used FOIL, as we say in the United States, or the special product formula that we would have the 1 squared and the xy, that quantity squared, but in between plus 2 times 1 times xy. Now notice that xy quantity squared is the same as x squared y squared. I'm also going to multiply things out on the left-hand side. Subtract 1 from both sides and subtract x squared y squared from both sides. Again, that's not going to change the direction of the inequality symbol. That would only happen if we were multiplying or dividing. That would only happen if we were multiplying or dividing by negative. That's starting to look a lot simpler. And we are just 2 steps away from seeing something that is true. Subtract 2xy from both sides, and then factor the left-hand side as the quantity x minus y, all of that squared. Now, we don't know what numbers, except that they're real, that we're putting in for x and y. We don't know what x minus y would be, but that's going to be real. And when you square a real number, you're going to get something non-negative. That's a true statement. Now, the question is, can we reverse this thinking and start out with this and get back to what was being claimed so that we really have a proof? That's coming next. Also, coming a little later, was this the best approach? We shall see.